Good day. I'm Nino James Andrew M. Palacio from BS Biology 3A. The topic that I choose under Assessment 2 is entitled Atomic Absorption Spectrometry or the AAS. For this video presentation, I will discuss the importance and application of the topic that I choose. To begin with, I will define first what is atomic absorption spectrometry or the AAS. Atomic absorption spectrometry detects elements in either liquid or solid samples through the application of characteristic wavelengths of electromagnetic radiation from light source. Individual elements will absorb wavelengths differently, and these absorbance are measured against standards. In effect, AAS take advantage of the different radiation wavelengths that are absorbed by different atoms. In AAS, analytes are first atomized so that their characteristic wavelengths are emitted and recorded. Then, during excitation, electrons move up one energy level in their respective atoms, as we can see in this figure number 1. When those atoms absorb a specific energy, this energy corresponds to a specific wavelength that is characteristic of the element. Depending on the light wavelength and its intensity, specific element can be detected and their concentration measured. As electrons return to their original energy state, they emit energy in the form of light, as we can see in this figure number 2. In addition, what is atomic absorption spectroscopy? Okay. One of the most frequently used tools in analytical chemistry. This is because for the determination of most metals and metalloids, the technique offers sufficient sensitivity for many applications and is relatively interference-free. Spectroscopy is the study of how radiated energy and materials interact. Matter absorbs energy, which will create some sort of change in its state. The atomic part refers to the atoms in a material which will absorb radiated energy from a light source. Those atoms will each have their own characteristics when it comes to absorbing energy because each element has a unique electronic structure. Therefore, using AAS, you can measure for a specific element in material based on that amount of light absorbed at a defined wavelength, which corresponds to the known characteristics of the element you are testing for. Kikita natin dito sa image. Note, AAS is also referred to as atomic absorption spectrometry. The difference between spectroscopy and spectrometry is that first, spectroscopy is the study of how energy and materials interact, wherein spectrometry refers to how you apply this as a measuring technique. Before I proceed with the importance of AAS, I have here a little trivia. Atomic absorption spectrometry was first discovered in 1802 when the English scientist William Hyde Wollaston observed and described dark lines in the sun's spectrum. However, it was not until the 1930s that this technique became more widely used. The importance of AAS. Metals occur naturally in the world around us, and around 3/4 of the Earth's chemical elements are metals. Sometimes, metals content in a material is desirable, but metals can also be contain contaminants. Therefore, measuring for metallic content is a critical part of many different processes. Although atomic absorption spectroscopy has been an established method for analysis of materials for metallic elements for many years, it remains a benchmark technique. First, this is because it has greater sensitivity than other methods, with less limitations. Next, for some liquid samples, it can provide direct analysis. Third one is also works accurately with very small sample sizes, making it rapid, efficient, and economical as a testing method. In clinical analysis, AAS can test metals in whole blood, plasma, urine, saliva, brain, and muscle tissue, the liver, and the hair. One example where atomic absorption spectroscopy can provide invaluable support is in measuring mercury levels in fish. Mercury is toxic to humans, but it occurs a metallic element in the environment. This poses a potential hazard to food chain. And last but not the least, AAS is a universally recognized method of analysis across the globe and an important tool in scientific research. Next, what are the applications of atomic absorption spectroscopy? Atomic absorption spectroscopy finds wide application in fields that vary from mining to pharmaceuticals, environmental control, and agriculture. Most heavy metals are toxic and should be avoided as far as possible. If you ever had to use an antibiotic, chances are that the quality control process to ensure that the drug is free from the catalyst, like palladium or platinum used to make them, was performed by an AAS. Similarly, the food and health supplement industries who make use of ASS to ensure that their products are safe for consumption. In mining, a lot of focus is on the recovery of precious metals like gold from old mine heaps. With the help of AAS, the amount of gold can be quantified to determine whether it would be profitable to extract it. The analysis of drinking water is probably one of the most important applications of AAS, especially in the place where the environment is not properly cared for. To wrap up with, the atomic absorption spectrometry, or the AAS, is relatively inexpensive and easy to use, while still offering high throughput quantitative analysis of metal content of solids and liquids. This makes it suitable for use in wide range